In this video, we'll look at interfacing a liquid crystal display with 8051. Now, we'll be discussing how to interface character LCDs or character liquid crystal display with the 8051. These are natural transitions from 7 segments and are very helpful in all your microcontroller based projects wherein you want to display text messages. Now, before you go ahead and look this video, I would urge you to watch the in-depth video about the graphics controller. So this is the graphics controller which we'll be discussing, HD44780, and we have done 2 in-depth videos on this, which you can go ahead and watch to get the basics clear. So any any LCD, any liquid crystal display will have a graphics controller inside, and that takes commands from the microcontroller and it displays the characters on the LCD. So most of the LCDs they use the HD44780 or a compatible LCD graphics controller. Now all the commands that we send from a microcontroller, they go to LCD, what do you call as a graphics controller like a 44780, and it displays on the LCD panel. So this is LCD panel and this is the LCD controller. Alright, so in order to understand an LCD better, it is required to understand the HD44780. Now, although we have done that in the video, let us just give a brush up. Now, a simple, and in the whole tutorial, we will be discussing interfacing a 16x2 LCD, which displays 16 characters on 2 lines. And you can as well extend these concepts to 16x1 or 20x4, so 20 characters or 4 line displays. Alright, so LCD basically will have the following pins. So there would be 2 pins for the power, which are VCC and ground, or ground of VCC. So, and then you would have a contrast pin, VEE, and you would have the register select, read write, and enable pins. And apart from that, you will have data bus D0 to D7, and you'll also have LED inside the controller which lights up the back panel, and there is an anode pin and a cathode pin for that. So what we simply do is we connect this to a power supply which is 5 volts, and even this is connected to 5 volts. We'll look at the hardware diagram later. So the point here is the signals that are used to interface with the controller are these. So basically we will have register select, then we have, this is register select, then we have read write, and then we have the enable pin. So these are used along with the data bus D0 to D7 to interface with the microcontroller. Now register select, when it is 0, it selects the command register inside the controller, inside the HD44780 graphics controller. When it is 1, it selects the data register. Now we can write this as read/write bar, so to understand it better. So when it is 0, commands or data is written into the LCD when read/write bar is 0. When it is 1, we read from the LCD. So we read either command or data. Now enable is something similar to a latch or a gating pulse. So we need to send a high to low pulse anytime we do any of these operations. So whenever we do a command read or command write, or data read or data write, we send enable pulse. Now what is the difference between command and data? So all the commands that the clear the display or set the cursor position or even define how many lines a display has and how many character it displays, all this is done by sending commands, and data is the actual data that we want to display on the LCD. So like this would be the actual data. Now so let us go ahead and look at what commands are available for us in order to set all the basics and all the characteristics of an LCD. So let us look at commands in detail. Now for all the commands, as you could guess, the register select this line should be 0, and since we will be writing all the commands into the graphics controller, we are writing data, so read/write bar would be 0 for all the commands that we discuss now. So this would be for all the commands. Now let us start with a few basics. One, so if register select and read write, if both are 0 and we send a command on the data lines, assuming we are discussing 8-bit mode, so for starter we will be discussing 8-bit mode where we have the entire data bus D0 to D7. Now so the first command would be to clear the LCD, and this would be 0x01 in hex. So if D7 and this is D0, if all the bits are 0, if all the bits are 0 and only if the D0 bit is 1, it clears the display. So this is in hex, so this it clears the display. And if the next bit is 1, if D1 is 1 and all of this is 0, then it sets the cursor to the first position, and it just takes the cursor from anywhere in the LCD to the home position. So this is command. Now this is don't care. So for 2 and 3, it just clears the display and get the cursor to the home position. Okay, so this would be 0x02 or 0x03. So this gets the cursor to home. Now the next command, it sets the entry mode, and this we discussed in depth in the first 2 basics video. So for this, the command would be all zeros, and this the one shifts here, and if you want to display a letter on LCD and we want to increment the cursor position, this 2 bits will be 1 and 0. Now to know why this is 1 and 0, please watch the previous videos. So this would be 0x06, and this sets the entry mode. Now what it does is, like say we are displaying a string hello, what it does is it displays H on the first position and then it increments the cursor to the next position. So we do not have to do anything to increment the cursor after we display a letter. So what it does is when we keep sending messages, it increments to the next position. Now the next command is basically turning on the display, the cursor, and whether you want to blink the cursor. Now that would be, so the one now shifts to the next position. This is called the D, which turns on the display. If it is 1, then the next is it turns on the cursor, and if you want to blink the cursor, blink the character on the current position of the LCD, B should be turned on. Now usually we turn on the display, we turn on the cursor, and we do not blink the LCD. So that would be 0x0E. So this is a display control. Alright, so the next command is display or cursor shift. So with this command we can shift the entire display or the cursor, and as you could guess, the one shifts here, and this bit is called S/C. So C stands for cursor here, and S stands for shifting the display itself. So, and as you could guess, if it is 1 it shifts the display, and if it is 0 it shifts only the cursor. Now the next bit is right or left, as you could guess. So if this is 1, it shifts towards right. If it is 0, it shifts towards left, and these two bits are don't care. So for us, the normal mode, we could use this in order to display, like say if the cursor position is at this and we want to take it back to the home position, and we do not want to alter the content here. So in that case we can use this command, and you can get the cursor here, and instead of H we can display another letter, or we could move the entire string from the first position to the next position. So to do that we use the display or cursor shift command, and since we will be not using this in the demo program, so we will not discuss it. So if you want to know the details, watch the previous video. Now the next command, as you could guess, so this is an important one. This one shifts here. Now this bit, it's called D/L. So this defines the display the interface length. So if it is 8-bit, if you are using LCD in 8-bit mode, this would be 1. If you are using in 4-bit mode, this would be 0. Now the next, it's called the N, number of lines. If it is 0, it is one line display. If it is 1, it is a 2-line display. So if it is 1, it will be 2-line display. Now the next would be, and the next is called the font, and if it is 5x8 font, then this would be 0, and if it is 5x10, this would be 1. Sorry for that. And then this is don't care. So if we calculate this for our 16x2 display, this would be 001. Since we are using for the first part, we'll be using the 8-bit mode, it would be 1, and this the number of lines is 2, so this will be 1, and we'll be using the default font size. So this would be 3:8. So this would be 0x38 for the 8-bit mode, and for the and we'll be also doing 4-bit mode. So for the 4-bit mode, this would be 0, this would be 1 again, so this would be 2:8. So this would be 2:8. This would be for 4-bit mode. Okay, so let me just clear this up. So there is no default for this, since I would be using 2 different commands with the 2 modes. So this would be 001. This is called display length. This bit is called number of lines. This is font size, and this is don't care. Okay, now sorry, this starts here, not here. Okay, so let me just correct that. So this is display length, this is font size, number of lines, and dash dash. Okay, now the next command, as you could guess, the one shifts here, and this is called the set CGRAM address. So now CGRAM, by the way, it's used to store custom characters, and so there are 6 bits that are remaining here. So the 2 to the power 6 is 64. This is 64 bytes of CG RAM. And to know more details, watch the previous video on how we can access and store data in the CG RAM. So this will be the next command, and we'll not be using this in the interfaces. Will not be doing custom characters. So possibly we'll upload code on the page to display custom characters, and you can download it from there. Now the next command would be, and obviously the last command, so the one gets here, and this bit is called the BZ flag. Now no, sorry, so this is not the BZ flag. Since this one gets here, so we have 7-bit address, and with this we actually display the contents of the DDRAM, or we set the DDRAM address. Now let me just spend a little time here. So what this does is, if this bit is 1 and we send a 7-bit address, it actually corresponds to a ASCII value in the CG-ROM. Now the terms could confuse you here, but it's pretty simple. The CG-RAM, it is used to store all the standard characters, like all your ASCII values. Now what this does is, it sets the address for the DDRAM. So when you need to store, when you need to write or read from DDRAM, you use this command. Now this is all about the commands that we could send, because the register select is 0 and read write is 0. So the commands that we write into the LCD. We'll see the next combination in just a while. So all that we discussed previously, register select was 0 and read write was 0. So this makes for the command register. So we selected the command register, and we all the commands were written to the display. Now we'll look at when the register select is 0, and when we read, what could we possibly read from the display. So there is only one thing that we could read: if the LCD is busy, or it is it is free and we can dump in the next character. And to do that, we simply do the register select as 0, read write as 1, and what we get back on the data bus, it's on the D7 bit, it's called the BZ flag, and the D6 to D0 we can discard all of this. So this gives important information here. If this bit is 1, it means that LCD is displaying something, so you cannot write or read the next command. So you have to wait till this 1 turns to a 0. So once the LCD finishes its internal operation, this becomes 0. And there's one more point to emphasize: you can interface LCD with or without BZ flag. So you're not too much concerned about the time the LCD takes to display a character. You can give sufficient delays and interface without the BZ flag. So this command, when register select is 0, read write is 1, it reads data from the LCD, and what it possibly reads is the BZ flag with the other bits. Actually it reads the current address of the DDRAM, but you do not consider that. So just check the BZ flag if you're using it in your program. Now the next command would be, the register select would be 1 in this case, and this is pretty important. So this makes it a data register, and what we usually do with this is we write data to the LCD. So the read write again would be 0. So we write data to the LCD. Now what we could possibly write is, we could write the ASCII characters. So when we send ASCII for, say, letter A on the data bus D7 to D0, the LCD takes it and displays it on the LCD. So the register select when it is 1 and read write is 0, the D7 to D0 bits, they will have data to be displayed. Now let us take a simple example rather. So say we want to display number 0. So the ASCII value for that would be 30 in hex. So that would be, this would be 0011. So this is 3 and this is 0. So this would be the data on the data bus. So if you want to display other characters, you need to send the ASCII values. And in the detailed videos we have discussed the graphics controller, you could actually write even custom characters and then display custom characters on LCD. For all that, you can watch the other video. Now you could be wondering about the last combination, so let me just clear that off. So in the last combination, again register select would be 1, wherein it refers to data, and read write would be 1. So what we'd be doing is possibly reading data from LCD. Now this is not of much help. We do not read data back from LCD, we only dump data onto it and display it. This could be again used in cases where you want to verify the contents of DD-RAM or the CG-RAM. So the one point to emphasize here is the CG-RAM, it stores the custom characters. You can rewrite, this is of 64 bytes, and you can store 8 characters. Now the DD-RAM is the display data RAM, or the RAM which is used by the graphics controller to display characters on the LCD. So this is about the basics. Now let us go ahead and look into what are the connections that are required to interface LCD in an 8-bit mode. So as you could guess, now the lines are not clear, let me just write them. So this it is the VCC and the ground pin. So the first pin it's ground, the second pin is VCC, the third pin it's the contrast. So as you could see, this is connected to a pot, and so for the pot, as you could trace here, this pin is ground and this pin is 5 volts. So when you vary the contrast between 0 to 5 volts, the contrast of the LCD varies. Now one thing to point out here is, you set the contrast such that before even you burn the program on the controller, you ensure that you have all square boxes on the first line of the display. So that sets the contrast. So you will not have to dump the program and not know what is happening. So first ensure that you get all the square blocks by setting the contrast on this pin. Now next, this is called the register select, this is read write, and this is enable. So you should be pretty familiar with them now. Now from here to here, this will be your data bus. So this is data bus 0 to data bus 7. As you could see, register select, read write and enable, these are connected to port 0 in the example, and the data bus is connected to port 2. Now this could be, so 7 is connected to 7, so this is DB7 and this is DB0, sorry for that. Now apart from this, for LCD to work, your controller should have other basic stuff. So you should have the crystal connected, you should have the reset, and you should power it up. So it could be through DC adapter or a battery. So these are the basic connections for an LCD for it to operate in 8-bit mode. And as you could observe, the 8-bit mode has all the data lines DB0 to DB7 connected to a microcontroller port pin. Next we'll go ahead and discuss what could be the possible way to write the software for this. Now usually our library has a LCD init function. So what this does is it initializes the LCD, so basically it resets it. So again, you could watch the basics video to know how to reset the LCD. Then what it does is it sets the function first, so it sets it as 5 cross so it sets it basically as a 16 cross 2 display, and it sets the data bus length as 8 bit, and then it selects the font size as 5 cross 8 as default. Now all this is done in the lcd init command. Now there are separate functions to write lcd command and data. So lcd cmd write, it writes all the commands to the lcd. So commands, as in case discussed earlier, the lcd display clear, display home, all the commands that you discussed earlier. So to write a character on lcd, so we use the lcd data write function, and it takes a character as input and it displays on the lcd. Now there are various other functions like the lcd display string. So it basically uses the data write function and it displays an entire string on the lcd. So it takes a string or string pointer as input. So if you pass a string, it displays the string on the lcd. Then there are other commands like lcd go to xy. So this sets the position on the lcd. So the first there are two inputs to it. The first is the line. So if it is 0, it is line 0. If it is 1, it is line 1 on the lcd. So this is x and this is y. So y is the cursor position. So let me just draw it here. So now if x is 1, so this is x is 0 and this is 1, and this is y. So y starts from 0 and ends at 15. So you want to set, you can, with this command you can set the cursor to any position, like say this is 0 and 8. So if you use lcd go to 0, 8, the cursor position goes here. Now and likewise there are commands to clear the display and all of that. Now let us look at lcd data write and lcd command write. So these two commands are used by all the other commands in the library, if you could see the structure, to do all the functions. Now lcd command write, again it is pretty simple. For this, what we do is we do register select, as since we are writing a command, we do register select as 0. Let me change the color here. So register select is 0. Read write, since we are writing all the commands, read write becomes 0. And then what we do is we have one more function which is called enable pulse. So this sends a pulse which latches this command into the lcd, and then we send the enable pulse. And before we send an enable pulse, we need to have the command, whatever command we have on the data line. So we keep the command first on D7 to D0, and then we send an enable pulse. So this is basically the flow for the lcd command write function. So this is lcd command write. Now similarly for lcd data write, as you could guess, the register select would be 1 since we are selecting data register. Again we are writing into the lcd, so this would be 0, and instead of command here we will have the actual data, the ASCII values, to be displayed on D7 to D0, and we send enable pulse. So this displays the data. Now if you want to know specific about the timings and all of the details, just watch the HD 44780 video. That would help you in a great way. So now, so these are basic commands and how the LCD uses it. Now the only difference for the 4-bit mode is the commands that we set to initialize the LCD. So as we will discuss, the function set, instead of setting it as 8-bit, it would be for the 4-bit. Now we'll go through the code at the end. So before we do that, we'll just see at what the difference would be for the 4-bit mode. So the only difference is, instead of 8 lines, we have 4 lines connected here. And one more important thing is, not the lower 4 lines, not the DB0 to DB3. The LCD will only work in 4-bit mode if it is connected from DB4 to DB7. So these 4 lines are used. So these 4 lines are used for data lines. The rest, everything else remains same. Now, before we go ahead and look at the actual code, so there is one more point which I would emphasize. So you could make the LCD work in 4 or 8-bit mode, and this can be with or without busy flag. Now in the code that we'll see next, we'll see it without busy flag, and we also have code for this which is uploaded on the tutorial page. Alright, so next we'll discuss the code, and then you will also have short demo which is done on the Ultra 8051 kit from Explore Embedded. You could possibly rig up your own circuit, or you could check the kit on our product page. Now in the next session we'll see about the actual code, and we'll show you a demo as to how the LCD works. Thank you for watching.